Chapter 11, Neural Network. We're going to look at a couple of examples. One is a very tiny example which we did in your class lesson. And then we will look at the accidents data where the target has three levels, 0, 1, and 2. So the tiny example will have just two level binary target. So we'll have one binary example and then one example with three levels of the target. And we will be looking at a couple of libraries. One is called NNET, NNet. Another one is neural net. And we will also use neural net tools library that allows us to plot the neural network. So we'll start with setting up our default path to the folder. Okay, we'll run that. Then we'll set up our libraries. Okay, so we'll have neural net, NNet, the neural net tools. Then we will use caret for running neural network within a tuning grid. Okay, now we'll run these four libraries. Okay, now let's bring in the data, and the data is simply, okay, let's put it in just df, and this is the tiny data. Tiny data CSV. Okay, so now we have the tiny data. Well, there are 6 observations. We have fat and salt and acceptance, whether they like it or not, like or dislike. Right? So that's our target. So we'll run, we'll save the results of the neural net in an object called NN, and we'll use the neural net procedure, right? And the first object is the formula, and we want to run, the target is acceptance, and we want to use these two, and there is another column called OBS, which is just the observation number. We don't want that, so therefore we have to set up the formula like this. So if I put a period, then the observation number will also get included. So I'm going to specify the predictor variables that we need, and that will be salt plus fat, and make sure that they are typed exactly the same with the capital F fat and capital S salt. Okay, the order doesn't matter. Okay, and then we specify the data equal to df, and now we can give the hidden equal to. Okay, now if you want only one hidden layer, then you just specify how many neurons we want. So suppose we want 3 neurons, then we put 3 there. But if you want to have more than one layer, okay, so neural net allows us to have more than one layer, in which case you give that as a list, and then so how many neurons you want in each layer. So like if you say 2 comma 3, so that means there will be 2 hidden layers. The first hidden layer will have 2 neurons, the second hidden layer will have 3 neurons. So I'm going to just say 3, and then there are several more parameters that we can set, and linear dot output, which is we say it's false, okay, with an F. Okay, so that means we have a classification problem. We have a target that is not an interval variable. which is, by the way, is a default, so it really doesn't matter whether we specify it or not. So we run that. I have a typo here. That should be fat and not fact. So now I run that. So it's done. And now we can look at the results. So if you do NN, we have net result. Okay, so that will give you the result. So we have the probabilities. Okay, there are two, one for like and one for dislike. And the neural net library sets up the information in such a way that the base procedure plot, okay, if you use that, it will give you the plot of the neural network. So plot NN, the network object that we just created, and you get the neural network. So we have the input, two neurons, salt and fat. Okay, output layer, two neurons, like and dislike, and then we specified only one hidden layer with three neurons. So now we have the weights here, and that's your bias. That for the hidden layer, and these for the output layer. Now if you look at the data with an str, so you see that the acceptance variable, that's our target, is a character variable, like and dislike. So neural net automatically figured out that that's a factor. It's not a numerical variable, and therefore it applied the classification method, and it gave you two neurons at the end. Now you can also do this by converting the target into a numerical variable. Let's so we'll set up a new column. So df accept num. Okay, now we're going to see whether the accept is like, and we want a 1 for that, and if it is unlike, we want a 0 for that. So df, well, start with the parenthesis, df acceptance, okay, is it like? Okay, so we use double equal sign because we are comparing. Okay, and when we so this will come out to be true or false. If it is like, then it will be true, otherwise it will be false. So to convert that into numerical value, we need to multiply by 1. Okay, now let's run that line. Okay, so now df, so it has a new column, so like is 1, dislike is 0. Okay. Now if you repeat the same code, okay, I'm going to copy paste these three. So okay, and we run that, and the answer is going to be slightly different because of the nature of neural net, where the weights are at, there are random decay values that are used, learning rate to update the weights. So it's not going to be exactly the same. So let's run the same thing, except that instead of acceptance, we will use accept num. Right? So everything else is the same. Okay, so now if you look at the results, and you see you get only one probability. So that is for accept equal to 1. Okay, because we have a numerical column that has binary value 0 or 1. So if you now plot, you see there is only one neuron for the column value equal to 1. And so in this case, our prediction is going to be whether these numbers are not actually probabilities, but they're very close, and therefore we treat these numbers as probability. So we say, okay, if it is greater than 0.5, then we will classify it as 1, otherwise not. In the previous case where we had two columns, we have one column of numbers that are very close to the probability of the target being equal to 1. The other one is 0. So well, the first one is 0, the second one is 1, and so we will whichever is maximum, the higher one is the one that we use as the class of prediction, the predicted class. Okay, now let's get the probability out of here, out of NN, and then we will do the class interval. I mean the predicted classification. So let's peel off the probability and put that in there. Now this is going to be a list, so we have to convert this into a data frame. So we do data frame. Okay. So once we have that, then we can say we can look at prediction, and we can use if else, right? Prob greater than 0.5, say like, otherwise dislike. Okay, so now we have the predictions. Okay, so that's our probabilities, and here is our prediction. Okay, then we can look at confusion matrix. Confusion matrix. Okay, so we have to provide the prediction first. So prediction has to be a factor. So we do as factor prediction. Okay, and then the actual class, again, that has to be as factor df acceptance. So the acceptance has like and dislike, and the pred has like and dislike as prediction. So now we can run this, and we have the positive class is dislike, and so if you want to specify positive equal to like, then you can change that and run it, and here you have the confusion matrix.